Okay. Hi. Is the sound okay? Okay, cool. So, I want to give a status update on Nouveau. Um, we kind of missed last year, so we are really sorry about that, but luckily it worked out this year, even though we missed the, CFP and everything. So, yeah, but yeah, let me just start. Um, that's still our goal. Like, I mean, we are sure we can't really promise performance expectation users might have from a normal open source OpenGL driver, but at least we are really trying hard to make it reliable. And we know that we have a lot of places where we still have a lot of issues, especially about reliability, but at least that's where we want to be in the future. And hopefully we get there at some point. But what actually happened since, the last time we gave this update, and I guess the most important feature for newer systems is that we finally support mode setting on Turing GPUs. So if you have a recent GPU, there's a high chance that you can use your displays with the Nouveau driver. I think it's still missing for really new GPUs, like some newer chipsets coming, which were released some months ago or something. That might still be missing, but at least, for most of the Turing GPUs, it should be fine now. There was also some atomic mode setting support, which is essentially for user space if you want to change the resolution, but something happens, like the cable is not reliable or something, that the kernel can automatically detect certain problems with that, and that you don't get to a state where you have a black screen. So that's quite important. I think there are a lot of X compositors which are buggy, so we don't kind of disable it on the kernel side, but hopefully we get there as well. And Lute was working on a lot of reverse prime improvements. It was like, when I'm looking at this, like 2 years ago or something, there were a lot of issues with reverse prime. Like the HDMI audio was not working, or the GPU wasn't powered on anymore. So there were a lot of random failures. And Lute did a good job to work on all of those and get it to a state where I think we can say it's good enough now, and there shouldn't be many issues left anymore. If you know of some, just yes.
Quick question: what is reverse prime?
Oh, reverse prime is if you have a laptop, and usually your desktop is rendered on an Intel GPU, but some of the laptops have external display ports like HDMI or DisplayPort wired to the NVIDIA GPU. So, like reverse prime is kind of the X term for it. So you kind of have to display it on the NVIDIA GPU and like copy the buffers and all that kind of stuff. Or maybe, I don't know how it's in detail, but yeah, that's kind of the thing.
It's called Optimus.
Yeah, Optimus is the marketing term for it, tied to NVIDIA. I don't know how it's called on Radeon GPUs, but yeah, that's kind of the thing. I was also working on having a near backend for Nouveau. So right now we can, compared to the old one where we use TGSI for the shader compilation, today we can also use near. It's still turned off by default, and or at least I hope, we can turn it on by default if it's reliable enough. I know that there are some regressions, but like supporting near is required, like not technically, but how we do stuff in MISA right now, it's kind of required for OpenCL, for Vulkan, and for OpenGL 4.6. And that's, I think, also one of the reasons why Ready on SI moved to nearby default, because it gives them this preview support, which is required for OpenGL 4.6. It would be cool if people would start testing it, like running it with games or their normal desktop or something. And we have an environmental variable for that you can set and then nearest used. For my testing I've done is I usually saw higher performance than with the TGSI perf, but I didn't spend time on any kind of performance optimizations. So if you test it and you see, oh, that one application is much slower than with the TGSI perf, then I would be really interested in knowing about this. Right. And also updates on OpenCL. I was working on that quite a lot last year. The initial support was merged quite recently, and it's right now, I think, kind of supported on firmware and newer. I only really tested it on Pascal, so there might be a lot of issues on other chipsets as well. I think Pierre is working on enabling it on Tesla as well, which is the generation before Fermi. And if somebody really, really wants to play around with that, we also have an environmental variable to enable it as well. I'm sure that none of the applications work right now, because like the shader, the kernel compilation isn't really finished at this point. But if anybody's interested in it and thinks, yeah, maybe I want to do some OpenCL driver stuff, there's this nice OpenCL conformance test suite, which is testing most of the OpenCL features. And yeah, it's, I would say it's much easier to fix those issues than, for example, jump into an OpenGL driver and figuring out what's wrong there. And because the runtime is much more, it's way more simpler, and it's more easy to follow what's actually going on there. I kind of called it staffing because, you know, as an open source project, we don't really do staffing, but I mean, we have a few paid developers. Besides myself, there's also Ben Skaggs working for Red Hat on the Nouveau driver full time. And we also have, for example, Lute, which is also part of the same team inside Red Hat, working a lot of fixing mostly display related Nouveau issues as well. I'm also, how do I phrase it, in the same team, but I can't really spend that much time on the actual issues I would like to work on. But I mean, it's still like paid developers. And we also have an intern at Red Hat, which is right now working on the Nouveau shader cache, which kind of helps with especially loading times of games and so on. And I think we did some testing. We saw like speed ups of 3 to 4 times faster over like shader compilation, because we can skip a lot of that in this area. I don't know how much relevant it's for games or something, but I hope that at least some games needing like 4 or 5 minutes won't take as long. Yes.
Nobody knew at NVIDIA working on a Nouveau?
I will come to that later.
Okay.
Don't forget to repeat the question.
Oh yeah, it was asked if there's anybody in NVIDIA working on Nouveau. Yeah, I will. Nouveau, NVIDIA will be a topic for later. Yeah, so we have also community members working on a Nouveau driver. I think the most present one is Ilya, which is doing a lot of, well, maybe not a lot, but he's doing quite some OpenGL stuff. He's implementing some new extensions, fixing random issues. He's also working on some display-related stuff. But yeah, I mean, big thanks to him, because he's spending like still working on the Nouveau driver. What's kind of like quite a few of developers 2 or 3 years ago, most of them essentially moved on, either by being hired by other companies and working on other drivers now, or maybe just lost interest or something, right? Which makes it really hard for us right now because we have a lot of issues to work on, or for example, also want to implement a Vulkan driver, but really don't have time for anything big anymore, essentially. And I mean, there are random contributions from random developers doing some stuff, but it's never something where I would say, oh yeah, this really stands out, or there is this new guy putting a lot of work or a lot of time into it. So yeah, it would be nice if I could kind of get more people interested into the project. I know that it's difficult to work with, and I know that a lot of people are kind of feared about doing hardware stuff. But I think if one is interested enough, they are able to work on that. Kind of like for myself, before I actually started to work on Nouveau, I was a Java backend developer. So I really did something completely different. I had no experience in hardware programming at all. And I kind of just jumped into the project because I was thinking, yeah, I have this NVIDIA GPU and I really want to have an open source driver for that. And there are issues, so I just started to work on that. And
So you make it sound like there's only hard stuff that are left. No, that's not true.
yeah.
It's 90% low hanging fruit. So if you have anything that you would like to go and work on, anything small, just go ahead and try to get it fast. Then you might get through.
Yeah, I mean, yes, Martin is right. There are a lot of low-hanging fruits. I have a slide later on where I kind of list some tasks people could work on, but yeah, I want to talk about this later. What's also interesting is like the working together with NVIDIA, negative stuff first, and I think that's the most annoying part, or most annoying thing for us right now is that getting firmware, because it has to be signed, otherwise the hardware doesn't execute it, and we needed to kind of access some states on the GPU. We are not allowed with unsigned firmware, and it's required, for example, for OpenGL. And what's kind of set, or what we would like to have is that if new hardware is released, that we get on the same day the hardware, the firmware for using those GPUs. I don't really have numbers on how long it takes in average, but I think we had a situation where it took around 1.5 years for some generation, but might be less, might be more. I really didn't look it up, so I don't want to make a concrete statement there. What's also annoying is, and it's true for power management as well, is we also need special firmware. The most annoying thing is on the second generation on Maxwell, we could reclock the GPU and we know enough to do it, but what needs signed firmware is controlling the fans. So you can have high speed, but the GPU would overheat because we can't make the fans faster. And that's annoying because, I mean, we are so close, but we still can't do it. And it's even worse on newer generations where even bits of the reclocking itself, like changing the voltage, is essentially locked unless you have signed firmware. And there were thoughts about doing the same we do also for the video acceleration, where you essentially extract it from the NVIDIA driver. But it's kind of really annoying because that would mean, yeah, distributions or user have to manually execute a script every time they install their distribution. Then it has to be extracted, and then we have to reverse engineer the interfaces, and those change essentially every driver version. So it would be super annoying and a lot of work we also don't have time for. So, yeah. But there are also good things in regards to NVIDIA is that overall, at least myself, I get the feeling that it's improving over time. It might be not that obvious to others because we also like I have to be a little bit careful what I'm talking about because we have some partnership with NVIDIA from Red Hat perspective, so I know a little bit more, but I can't really tell about much, right? But at least what we're working on with NVIDIA is getting documentation out. And they actually have a Git repository on GitHub. And you can essentially see the commit history, and there is some useful stuff going in there, especially documentation for the displays, interfaces. So what, how do we program the GPU to drive the display, and what we do, how to program the MMU as well, like for doing memory-related stuff. So that's super helpful, and I hope that there will be more useful documentation also for different areas, but we just have to wait and see what's happening there. Terry is employed by NVIDIA, and he also works on Tegra code mostly. I mean, he's doing upstreaming of a lot of Tegra bits for the core kernel, like just using the Tegra devices. And it's not that much Nouveau related, but there's also some Nouveau contributions to fixing random issues or having this Tegra Gallium driver as well. So that's also cool, and it's really good to see that there's at least some people at NVIDIA really dedicated to this. Also, there is on the mailing list, if you scroll through it or search for people with an NVIDIA email address, there are some patches from NVIDIA people, so which is also quite cool. And I hope there will be more in the future. So. Some stuff we are currently working on is the biggest thing, most likely, getting OpenGL 4.4 and 4.5 ready. There's this kind of requirement to pass the official Kronos conformance test suite. I think on some GPUs we are at the stage where we pass every test, but there are random failures if you run the full thing, because the full thing does 30 iterations of the test with different parameters. And last time I did this was the first failure was after 10 hours of running it, and it's super painful to debug, and it's probably some random issue of not initialized memory or something random. We have no idea, and I'm not really in the mood of having to wait for 10 hours to hit a bug just to debug it. So that's a little bit annoying, but we are getting there. And Ilya was also fixing a lot of issues, and myself as well. So hopefully soonish we get official OpenGL 4.5 support. We also would like to improve the performance. There are sometimes random shader optimizations landing in the tree. For example, also the near work could lead to improved performance, but sadly we really can't, do really big reworks to improve the performance in a way like the Intel guys or Radeon guys are doing, where they essentially use different interfaces of VISA or rework certain other areas. Building a CI system, we would also have something wired up to the FreeJoyStop GitLab CI system. I don't know if all of you heard about this, but right now we have a CI pipeline on the Git repository whenever somebody opens an MR or somebody pushes to the master branch, that we have this software and hardware pipeline testing if commits regress something. So we do test the software vendors, but there are also instances really testing it on hardware. And I would kind of want to have the same for Nouveau as well. I kind of have to see like how much time it consumes, because maintaining such a system can be very time consuming, but let's see how that goes. Right, OpenCL support, it's also what we are still working on. And I hope I will be done with it soonish. There are a few kernel compilation stuff we still have to figure out. But yeah. And what we also right now working on is getting OpenGL support for Vultr and Turing. Vultr isn't really relevant to any users because I don't think anybody has this super expensive Vultr GPU, but it's kind of similar to Turing, so it's essentially the same work. And once we get the firmware for hardware acceleration for those as well, we want to have this be done inside Mesa as well, so people can users can finally use OpenGL on Turing GPUs as well. Important things we really want to fix is, I think the most prominent issue is the runtime power management issue. There are a lot of laptops where you have an NVIDIA GPU, and when we turn it off, then it fails to turn on. And usually it leads to the system crashing or people not being able to boot the Linux installer, and then they have to disable the runtime power management stuff. What's kind of annoying about this issue is that I have no idea what's wrong there, and nobody else was able to help as well. So I was talking with upstream developers about this issue, and there was no real conclusion on that either. We also have no idea if it's a driver bug inside Nouveau, or maybe it's a hardware bug, or maybe it's a kernel bug. What's kind of interesting that it only happens with a certain Intel bridge controller and not with any else. So maybe it's a hardware bug, but the biggest problem is just that the firmware code involved with turning off the GPU is accessing undocumented registers. So we don't even know if what we are doing is even correct, or maybe we have to do some things before doing so. But there's also no public documentation on that, so that's super annoying to fix.
Is it coming up from NVIDIA? Some serious help?
Excuse me?
Is some serious help in that direction?
So the question is if there's any help from NVIDIA from that direction. Kind of.
Kind of.
I can't really.
Promises with no real information yet.
No, there's not anything useful coming out. What I kind of hoped what would happen, because the official NVIDIA driver supports this on the latest driver for Turing GPUs as well. So they have now support for turning off and on the GPU. But if we do it on Turing with Nouveau, it works. So I can't really say, maybe, like, I would like to reverse engineer it with older GPUs, but if the driver doesn't support it, I can't do it as well. And I mean, I tried to request information from NVIDIA on this, but they...
Okay.
I really don't know. I mean, I didn't get anything useful. Let's put it this way.
Does the similar issue happen if you do the hardware passcode to virtual machine to have KVM, for example?
So, just a comment or a question?
Does this similar
Oh.
does this issue happen when you do that?
So the question kind of was that a similar thing happens with device pass-through as well, and if like it's kind of related or not. Now it's a different thing. I mean, it's totally unrelated. The runtime power management is usually something which is only implemented in laptop firmware. So it's really a firmware level feature of cutting the power on the PCIe device. I'm aware of a few issues with device pass-through, yeah, but no, it's a different thing. What might also be relevant in the future is that right now devices are not hot unpluggable. This is mostly relevant for eGPU cases where users have their case and they are unplugging the device and then the kernel just crashes right now. So I noticed that on a few generations it doesn't crash, but user space is still screwed up. The most annoying, it's one of the bigger rework we would like to do because it essentially touches all of the driver, because at any point the device can just vanish and you kind of have to deal with it in the kernel driver. And kernel drivers for GPUs are quite huge. And if you have this assumption that, like, if you lose the assumption of, yes, my device is always there, a lot of things you can't really rely on anymore. Because right now, if there is, if you want to access device memory, we just do it, right? There's no check for, is the device still there or not? So yeah, it's a little bit bigger rework, but if somebody is interested on fixing this, the biggest advantage is that there's no hardware knowledge required at all. I mean, it's essentially just, unplugging it and you see this kernel crash and then you try to figure out how to fix it. It's kind of straightforward, but it's a lot of work. So what we also really would like to fix in user space or work on is multi-threading. That's mostly an issue which comes up with Chromium, for example, because they're doing multiple context, OpenGL context in the same, different.
Is the reason that Google turned it off, hardware acceleration? If I run Chrome or Chromium on Nouveau, there's no hardware acceleration.
Yes. So
and if I turn it on, I get problems on various websites. That's what you mentioned
That's one of the reasons.
Yeah.
I mean, there are also other reliability issues because, rendering can fail, or there can be random corruptions. But I think what really drove the decision from Google was that the multi-threading thing really causes the GPU to just, or the application to just crash. And what's also happening is there are a lot of Chromium-based applications which also have to maintain their own blacklist, I think. So there are other applications having the same issue and essentially just crashing. There are also a few games, I think, doing multi-threaded rendering or OpenGL. And kind of the core issue is that we just corrupt the application state or the Mesa state as well. So we send invalid commands to the GPU, and then the GPU might also just crash. And sometimes the Mesa just crashes, so it's really annoying. But yeah, we would like to work on or fix that. We also would like to have a Vulkan driver. I think right now the main reason why we can't do that is because we would like to have a new kernel interface for the Nouveau driver in order to properly implement Vulkan as well, which also would require us to rework the Mesa driver at some point as well, but it would lead to a more reliable driver. Context recovery is also kind of something a lot of drivers are implementing as well, is that even sometimes it can happen that the GPU context or the GPU just crashes. And we would like to recover from that. In the past, what I've saw and some users as well is that it could happen that the GPU context crashes, user space never knows about this, and X just freezes. So the user is not able to do anything. They can't even switch to the TTY. in order to restart X or something. So they just have their machine, nothing happens anymore, and they have to essentially force reboot. There are some improvements with that, with the 5.6 kernel, and hopefully most applications will now just crash if that happens. But if anybody of you have this case with the updated kernel that, or you still have a freeze and your system just doesn't do anything anymore, then just contact us and we will see like what's the reason for this. But hopefully that doesn't happen anymore. Question?
Do you have any kind of guesstimate of how many years away like a reliable Qualcomm driver would be?
So the question was, how many years are we away from a reliable Vulkan driver? I don't know. I mean, Vulkan driver is usually less work than an OpenGL driver, but there are also a lot of additions to Vulkan happening. So I really don't know. I mean, hopefully it's not that far away.
Combined forces together with Intel
Oh,
and AMD that also want a
Yeah.
Vulkan driver.
so yes, but we are already having shared stuff with Intel and AMD on the Visa driver. So there are some common things, especially the Spurvy compiler stuff, because Vulkan requires Spurvy, and we have the Spurvy to near thing inside Mesa, which is shared by all the Vulkan drivers. So at least in this area, we can just make use of what's already there. There's also like dispatching stuff, like if you call a Vulkan function, then like the runtime has to check, oh, does it actually is implemented by the driver or not? So there are also shared code in this area. I think there are other bits as well. But yeah, I mean, there is stuff like this. And I think the main goal is to get to a point where drivers really only have to implement their hardware-specific bits. What we also would like to work on is mainly debugging features. Right now, if we encounter a bug, it's usually always a lot of work to figure out what's actually happening there. For example, we can't debug a shader, which is super annoying, so we can't see, oh, what's the value of this register, or why did this shader loop forever or something. It's really painful to debug right now such issues, because it usually means, oh yeah, I have to adjust the GLSL code to figure out, oh, why does something happen. That usually takes more time than, for example, let's say just turn on a debugger and see what the shader is doing. So we can't do that. We would like to do that. There was some reverse engineering in this direction done already, like a lot of years ago, but yeah, it's not implemented yet. So, and if anybody is interested to help us out on that, and has essentially NVIDIA GPUs and has these issues or something, it's always a good idea to try to look into that themselves. I mean, that's how I started to work on Nouveau. I just had I had issues related to reclocking, and I was looking into it and figure out like, what's wrong. And if there are some issues which really annoys you and you would like to get it fixed, you could also you could try to look into this as well. We can always help with stuff. So if they're like, yeah, if you're interested, just try to do this, please. Being interested and motivated also is kind of a huge thing, of course. If you are not motivated, then nothing will come out of it. And especially for students, if they also want to get some money while doing that, we would be happy to do also GSOC or EVOC programs, which is essentially kind of, you get money to work on an open source project as an intern, like kind of intern like. I mean, you can't really say it. It's not an internship, but it's essentially, there is some evaluation going on, and we say, okay, this person is skilled enough to work on that, and then they get paid for, I think, GSOC is 3 months. I don't know the details of eWork, but yeah, so there's money, and you're working on open source projects. What's also kind of good entry-level task is compiler optimizations. Most of you, or some of you might have think, oh, but that sounds super complicated, but a lot of optimizations are just simple math. So you have, you know, special patterns and shaders which you can reduce to a simpler set of instructions just by applying some math to it, essentially. There are also like more complicated compiler optimizations, but that's kind of the more trivial ones where you just see, oh, maybe there's a shift in the left direction and in the right direction. Maybe I can also just apply an AND if it's by the same amount of bits. So, what's also kind of fun project would be to use some GPIOs. There are several of them on NVIDIA GPUs. Some of them just control the LEDs on GPUs, for example. Some of them get triggered when you don't have the external power connected to the GPU. And there are a lot of random stuff like this. Maybe if some is more keen to work on hardware level stuff, that's also something cool to work on. And we also have some fan controlling issues where we actually got documentation for as well. And it's still like a thing on our to-do list, but if somebody else has a GPU where the fan controlling is really odd, like if you have more load, the fans could get slower. I have a GPU like that myself as well. Which is something which shouldn't happen, but if you find such odd issues with your GPU as well, maybe if you want to look into it, that would also be a cool thing to look into. Yeah. I think I'm done. There are a few links you can always look into as well. Mostly we are on the IRC channel around and talking with users if they have complaints or bugs or something. And we also have the Trello board where a lot of tasks are listed. Maybe I can open it. Yeah. But I think that's essentially it. Yeah, so I don't have anything anymore. Any questions or comments or maybe even suggestions?
It might be good to have the Trello board linked on the development page because I don't think it is.
I thought it's on the wiki.
It might be elsewhere.
Yeah, I'm sure it's there, but if it's not, then yeah.
Do you need to support the Quattro branded GPUs specifically compared to GeForce, or is it just a matter of generations of them?
The question was if we have to do anything special for Quattro GPUs. No, we don't. It's essentially the same GPU. I think there are some Quattro cards which have certain hardware features enabled, like double floating point precision performance. Usually on GeForce cards you have really slow double precision performance, but it doesn't matter because games are not using it. But besides that, I'm not really aware of anything. I mean, what I was actually working on is that in the past, if you use the NVIDIA driver only on Quattro cards, you got the power consumption. And I've implemented it for GeForce cards as well, in Nouveau. Because it was just really a software check to turn it on or off in the NVIDIA stack. But yeah, generally it's the same. Yes?
So I was curious about the version of OpenCL that you are targeting, or just
Yeah. So the question was what OpenCL version we are targeting. Right now, the OpenCL runtime in MISA is implemented on a 1.1 level. And at least that's what we are trying to match. But I was also working on some OpenCL 2.0 features, or Pierre was also working on consuming SPIRV, which is an OpenCL 2.1 feature. So yeah, I mean, there are interested features in OpenCL 1 which are cool to implement. But yeah, I mean, right now we are trying to get it to work first and then look into implementing more features. Yeah. Yes.
How about legacy products or generation of video hardware? I have an old car, low profile, for example, the sound is really noisy and it's hot. So I'd like, but I never managed to develop it. It's still development for those old cars.
So the question was if there's still development for old cards. Yes, if somebody has time to look into it. Yeah. So I mean, the kind of the bad and the good thing is we are not a company, so we can just take care of issues on older hardware because we don't have the pressure on only supporting the newest thing because we want to sell hardware. But on the other hand, we also don't have enough people to look into all the issues. If there's a bug on like 10 years old GPU and somebody fixes it, then we also would like to merge it, yes. Yes.
So I saw that you have some paid co-developers. Who pays for this work and why? What is the interest of this
So Red Hat is paying for all of them. And the reason for doing so is just because of RHEL. Well, Red Hat Enterprise Linux. And I mean, it supports the desktop, and because you want to make use of the GPU as well, you need the Nouveau driver because Red Hat doesn't want to ship any proprietary blobs, so Nouveau is the only thing.
When you receive a signed firmware from NVIDIA for reclocking and the fun control, does that require any additional work in Nouveau itself?
The question was if using the firmware provided from NVIDIA causes additional work. Yes, the firmware is executed on coprocessors on the GPU, and you also need a communication channel to these chips as well, to the CPUs as well. So that's one thing we have to work on. Also, the signature stuff, like because they are signed, requires a booting process which gets more complicated by the generation. So you have like a core security chip which has to get booted, and then it boots the other processors with other firmware, and the signature stuff is different again, and you have to allocate secure memory so the driver can't tamper with it while the boot process is ongoing and stuff like that. Yeah, so that's kind of the thing, which the positive the advantage of doing the getting the firmware is we don't have to implement the firmware ourselves. That's what we've done on older generations where we have the firmware for power management, especially useful for on Tesla and Kepler because we do the memory reclocking on the PMU, which is one of the coprocessors, but we also have firmware for context switching. So if you have multiple hardware contexts on a GPU, they have to get switched at some point, and on NVIDIA GPU, that's also done on those coprocessors. Yes?
Now that Red Hat belongs to IBM, is it possible for them to put more weight behind all of this?
I mean,
Can you repeat the question?
yeah, the question is if now that Red Hat got bought by IBM, if they are able to put more money into it. I mean, they certainly could because it's a bigger company with more money than the Red Hat, but even if I would know about plans, I wouldn't be allowed to talk about it. Right? So, yeah, I mean, the most obvious thing is, yes, they could because they have more money.
Must be okay.
I don't know. Yes?
So when you talk about the debugging, you mentioned that there is probably some memory corruption going on. So is it possible to have address sanitizer or something like that to build a kernel module?
No, the question was that because I was talking about debugging, if there's memory corruptions, why we can't use like address sanitizer. I was talking about GPU debugging. Yeah, like all the sanitizers don't work with GPU memory. So
Right, it's memory corruption on GPU, not
yeah.
user.
So
Oh.
yes, I mean, for example, the multi-threading issues we can fix with the address sanitizer. The problem is just that the cause is much more complicated than just throwing in some logs. Because if you throw in too many logs, then the performance goes down. So there's no benefit of doing multi-threading. No? Sure, we could, but also kind of the architecture of how we're doing things make it really annoying to do so. Yeah.
Is it at least possible to make a log of what's driven, put into the GPU, and then when it dies, have at least a backtrack of what happened before? So not you cannot read state anymore when it's crashed, but then you can at least see what was the last thing happened before it stopped responding.
So the question
Not
was.
slow down things, of course, but
So the question was if we could throw in a log so we know what's happened last on the GPU before it crashed. Yes, we have that. With 5.6, Ben added a feature where I don't even know. No, it's a kernel feature where if you send commands to the GPU, you can do it in a synchronous way. And if the GPU crashes, we know what command submission was done last. It helps a bit, but the command submission can also be like 100 or 1,000 comments. But yeah, I mean, we could also do the command submission smaller than, and then figuring out what's happened. So yeah, we have something like this now. Yeah. Okay. Okay, then I think I'm done.